This one's going to be pretty intense. I'll just go ahead and line it up really quickly. Uh, Celeste, one of our daughters, drew that. I thought I'd put him up there because, well, let's be honest, that green man's amazing looking. But this one is stellar metamorphosis of Pongola-like glaciation on Uranus. I know astronomers just sort of ignore that object, and it's the brunt of a lot of jokes. But I guess I'll do my best and make this talk a little serious. But abstract: if Uranus is on a similar transformation curve as Earth was, then it is just beginning its own Pongola glaciation. For those new to this theory, I have Neptune is 1.1531 plus or minus 0.1125 billion years old. So 1.1 billion years old is Neptune. And Uranus is about 1.237 billion years old. They're about a fourth the age of the Earth. The Pongola glaciation on the Earth happened when the Earth was 1.3 to 1.7 billion years. Their little graph here. I know it's kind of hard to see, but there it is. Here's the Huronian glaciation on the Earth. And Earth obviously is way down here. And this is where, let's see, who's that? Neptune is right now, and that's where Uranus is right now. And I have Uranus is probably starting its own Pongola glaciation, give its own the same transformation curve as the Earth. For those who are new to this theory, a transformation curve is just a curve that goes down here as the star evolves. So it can start up here and go up high right here. It can start down low over here and go over here. It could lose mass really quickly and just become a dead world. But it's very advanced, and I don't want to go over the whole theory right now. I just want to discuss this real quickly. And Neptune is about right there. Uranus is about right there. And Earth, see, Earth is about right there. Yeah, and Mars is about right there. Mars is basically a dead world. It's already passed all of those other stages. I have no idea why Elon Musk would ever want to go there. It's a dead, there's no atmosphere. I mean, very little atmosphere. It's cold as hell. Why? Why? If you want to go somewhere, go to Ocean World, or at least take humanity into our own oceans if the surface becomes mostly uninhabitable. If the radiation is too strong and the atmosphere is mostly gone, then go into the oceans. There's a lot of three-dimensional space there to hide out in. But Uranus to Earth transformation curve is right here. I have Uranus possibly being on the same transformation curve. And in this paper, I'll read this out to you really quickly. What this could possibly mean, given Uranus and Earth are on a similar transformation curve, is that we can see what Earth looked like 3,200 to 2,800 million years ago. It also means we can know almost exactly what is occurring deep in the interior of Uranus by studying the oldest geological structures on the Earth. Thus, we can infer more correctly the conditions that specific life forms began in, including stromatolites. Earth life, switching from chemical processes to more complex biochemical processes, began in the deep interior of evolving stars, and were not exactly reliant on the heat from external stars, but on their own internally produced heat. This is also direct evidence that the first microbes were formed under extreme pressures much higher than those found on Earth today. That's a lot there for my newcomers. Low pressure life is quite young, and high pressure life is ancient as a rule of thumb. What this could also mean is that life began deep and worked its way outwards, eventually just adjusting to the lower pressures of atmosphere as it is ripped away, giving indirect cause for extinction events. In fact, it also gives cause for extinctions being transitional states as the atmosphere changes composition and density, and not caused by unique single time events such as a giant asteroid strike. The life did not go extinct as if it just disappeared. It evolved to adjust to changing atmospheric conditions. And that's a big one. I think Octavie Levenspel did a paper, and it said the dinosaurs probably lived in an atmosphere of at least 3 to 5 bar. 3 to 5 bar is 3 to 5 atmospheric pressure. Pretty pressurized outer area. But we know why Earth was probably higher pressure in the past because, well, it had a huge atmosphere. And as you go further and further back in time, the atmosphere was much more pressurized. Eventually, it goes way up here. I don't have it on here, but this is where the really bright hot stars are when they're very young. Yeah, that's basically that.